Welcome to Amiga Tutors. This is Anushua. Today I will be teaching you guys number systems. Now let's start. So, number systems. So, today I will be representing all of the numbers in a line. So I think now you guys are aware of what are the positive numbers, what are the negative numbers. Positive numbers are 1, 2, 3, 4, 5, 6 and all, and negative numbers are -1, -2, -3. Okay, so I am representing all of the numbers in a line. And if this is 0, this will be this will be +1. You can write 1 as well. 2, 3, 4 and so on. And this will be -1, -2, -3, -4 and so on. So now let's imagine a guy is going across this line and he is picking all of the numbers 1, 2, 3, 4 and so on. So now in his basket there are numbers 1, 2, 3, 4 and all. Then these all are called natural numbers. Okay. Now let's assume the guy is picking 0 as well. Okay. Then in his basket what the numbers will be 0, 1, 2, 3, 4 and so on. Now if 0 is included, then it is called whole numbers. Okay. Now if the guy picks 1 also, -1, -2, -3 and so on, these all of the numbers, these all negative numbers. Okay. So what will be in his basket? That is -3, -2, -1, 0, 1, 2, 3, 4, all of the things. Okay. So behind -3 there are also many negative numbers. Then this is called integers. Okay. Now there are many numbers within 0, 1 or 0, 2 or 0, -1. Okay. So within these things what will be the numbers? That is here or here. So this will be half or this will be -half. So these numbers are in the form of ratio. So if the numbers are in the form of ratio, then it's called rational number. Okay. So then what will be in his basket? Within the basket there will be -3, -2, -1, -half, 0, half, 3/4, 4/5, 1, 2, 3, 4 and so on. Now you guys can think half can be represented by a ratio, that is the denominator and numerator. There are a numerator and denominator, right? But for 1, 2, 3, these are also rational numbers, because 2 can be represented as 2 by 1, right? Or 3 can be represented as 3 by 1. So there are numerator and denominator both. So this rational number includes all of these numbers as well. Now, what are irrational numbers? Irrational numbers, just the opposite of rational number. Rational number can be represented by in the form of ratio, and irrational number cannot be represented by in a form of ratio. Okay. So it cannot be represented in a form of ratio. What are the examples? Like root 2. Root 2 can be written as root to the power half. You know, right? 2 to the power half. So, okay. So 2 to the power half, because the value of it is 1.414 dot 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 dot, because this cannot be ended. Or 3 to the power half, that is root 3. So this can be represented as 1.732 dot 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 dot, and out of this cannot be ended. So this cannot be represented in a form of ratio. So these all are called irrational numbers. Now, what is 4 to the power half? 4 to the power half, that means root 4. Root 4 is 2. So 2 is again a rational number, right? So it is not an irrational number. That is, you cannot get a definite number from that thing. That is root 5. Root 5 is also a irrational number. It cannot be rooted. Okay. So all of these things are irrational numbers. Okay. So now, how can you represent 2 to the power half, that is root 2, in a line number? How can it be possible? So I am refreshing the page actually, so that you guys can understand. Okay. Now I'm again drawing a line and representing different numbers in that line. So this is 0, this is 1, this is 2, this is 3, and this is 4, and here it is minus 1, minus 2, minus 3, minus 4, minus 5, and so on. Now within 0 and 1, okay, the gap is what? The gap is 1, right? The value is 1, right? And now I am taking the same thing, that is, from 1 I am drawing a perpendicular of the length 1. Okay, so this length is 1, this length is 1, and this length is also 1, right? And now we are drawing, and this is perpendicular as well, so I am representing it as perpendicular. This is 90 degrees, and now I am joining these two in a line. Okay. So now this becomes a right angle triangle. This is 1, this is 1. So this will be root of 1 square and 1 square, right? So this will be root of 1 square means 1 plus 1 square means 1. So okay, let's put a square and let's put here a square. Okay. So this is 1 square means 1 and 1 square means 1. Then 1 plus 1, that will be equal to root 2, right? That is equal to root 2. Okay. So the value is here, it will be root 2. Root 2 can be represented as 2 to the power half. I told you, right? So this is root 2. Now you can take a compass from here. You can put the compass here and you can draw the line from here to here. Okay. So this value, that will be root 2, right? Because these both are in the same length. Okay. So this is root 2. So like same thing, you can draw what will be root 3 in a line number. So what will be root 3? That is 1.732. So that will be behind 2, and for that you can draw a perpendicular from this line to here. Okay, that should be a perpendicular of this line. So this is a perpendicular. This is a perpendicular. This is 1. This is 1. Okay, and I am joining this line with this. So what will be the value of this? This is a right angle triangle, and as per Pythagoras theorem, this is the hypotenuse, right? And for that hypotenuse, what will be the formula? That is root 2 square plus 1 square, right? So what will be the value of it? Root 2 square is 2 and 1 square is 1. That means 2 plus 1 equal to root 3. So thus this value is root 3. Okay. Now you can take a compass from here to here and you can represent it like from here. You can draw in compass up to here. It will come like this. Okay. So if you draw compass like this, so this length is the value of root 3. Okay. And this is root 3. So thus you can get how root 5 it will be. You can try in home, at home as well. What will be root 5 or root 6 or root 7 or root 8, whatever it is. So you can try all of these things at your home and you can get back to me. We will be coming soon with another tutorial. This is just a demo of number systems. You can go through all of this and please please give some reviews of this video, how you guys are liking this video, and give us feedback based on all of this. Okay, so thank you students, bye for now, take care.